Hi and welcome to AXSChat. I'm delighted that our guest today is Peter Mahoney. Peter is the SVP of Nuance, particularly focusing on the Dragon business, which is actually my favorite bit of assistive technology. Been using it since the turn of the millennium. Um, Delighted to have you with us, Peter. And also you also do work with Easter Seals, which is another great organization. So we've got lots to talk about today. So please tell us a little bit about how you came to work in the field of assistive tech, and then also a little bit about how you came to be working with Easter Seals.
Sure. No, that's great, and thank you very much for having me, Neil. I'm really excited to be part of the discussion here. This is an incredibly important area for me personally, as well as for Nuance. Let me give you the brief history. I won't start at birth, but I'll give you the brief history of my involvement with assistive tech. It actually started in the mid-1980s. I was a student at Boston College. I had my degree in physics and computer science, and one of my closest advisors was a guy by the name of Dr. Jim Gibbs. And Dr. Gibbs invented a technology called Eagle Eyes that some people may have seen, which is an eye tracking technology. But back in the mid 1980s, when he was a young professor, computer science professor at BC, he was doing some work with the campus school at BC, which is a school for children and young adults with profound disabilities, and he had me do some research projects for him. And in particular, my senior thesis project was around building an input method for people with very limited mobility, so sort of push-button spelling input method for folks using a hacked Apple II computer where we could build our own hardware for a closed hardware platform, which was interesting. So that was my earliest involvement, and was always fascinated with the organization, with the concept of assistive technology. And then fast forward to 2001, well, no, she'll be mad at me for doing this. 1998 is when my middle child was born. My daughter Marianne has spina bifida, spinal cord defect. And as a result, I had to sort of conjure back up all of my experience in assistive technology, which has been quite valuable for me to help her sort of hack the world and try to incorporate different kinds of assistive technology into her life. I got involved with Nuance back in 2004 for the first time, and started running the Dragon business around voice technology, and finally connected the dots together where my work in my life, in my education came together for the first time. So I was quite excited about that. And then back about 4 years ago, I was doing accepting an award on behalf of Nuance from the Disability Law Center in Massachusetts for our work around disability technology. And the CEO of Easter Seals Massachusetts heard my story and came and tackled me after and recruited me to be on the board of Easter Seals in Massachusetts, and it's been a great relationship there. Now I'm the chairman of the board and very active in Easter Seals. So that's a very long story of about 30 years in about 1 minute.
That's very good. You've obviously well practiced this, because it's the art of knowing how to dictate, obviously.
That's right.
So I know that Nuance does a lot of work around speech recognition, and you've got some fantastic products, particularly the Dragon desktop product, but you're also now doing mobile. But you also make all of the sort of text-to-speech products as well. So it's not just speech in, it's speech out. So effectively, the business that you're part of is actually the powerhouse behind a lot of the assistive technologies that our core user base are using all of the time. And for me, it's exciting because you do a lot of innovation. So what are the things that are exciting you right now in speech and natural language technologies? Because it's a really fascinating area.
Yeah, it really is, Neil, and it's interesting because the way we often think about it, we think about these technologies at their component level, right? We think about uh, voice to voice to text and text to speech back out again, and it's because we've had this history in assistive technology of leaving the integration of all the parts up to the user, which in some ways is okay because, of course, assistive technology needs to be applied very broadly and creatively because people's disabilities are so variable. They're as variable as people are. But at the same time, there's an opportunity to really bring these things together. And that's where a lot of the future work is headed. It's taking the elemental technologies and putting it together into a more intelligent system that becomes a more conversational interface with computing and technology overall. And you see this certainly in some technologies that are in the marketplace today. Think Siri or Google Now or even Amazon Echo are great examples of starting to put these pieces together. And you'll see more and more of that, as we and others start to innovate more in really making the computing platforms that we deal with on a daily basis just much more aware and capable of interacting with human beings in a way that interacts at their level versus forcing us to speak computer language. A funny aside, when I started programming back in the 1970s, I started programming on punch cards. So literally, you had to punch these holes in a card, and your younger viewers won't understand what this is or believe it when I say it. But you had to sort of punch holes in a card with a card punch machine, and then the computer would read it in. And it was the ultimate in basically making humans communicate the way that machines wanted to communicate. So we believe that that's backwards. In the reality, we think that computing should be able, it's smart enough, it should be able to interact the way that people want to communicate. And of course, people with differing abilities communicate in different ways, and the innovation that we're working on is really making these computing technologies more flexible to understand the way that people want to communicate so that they can have a valuable interaction without forcing us to speak the way computers want to speak.
Okay, I know that both Deborah and Antonio have got questions, but I just want to follow up on that last point, because I used to do scripting for Dragon and spend a long time as actually a Dragon reseller in my previous job. So really like the product, but what you're talking about is making it much easier for consumers to change these things around, right? And so it's a case of knitting this into the day-to-day computing experience rather than it being a sort of distinct thing and there only being certain products. What I'm hoping for, my nirvana, would be a speech-enabled world around us where you can talk to your computer and it works out but what you're saying, and it truly is natural language rather than natural-ish language, which is what we've been for a number of years.
Yeah, I think that's right, Neil, and it is an evolution, because if you think about it, we've had some limited natural language capability within Dragon for some period of time, and it tends to be in a very specific domain. It's an area where, for example, some of our natural language commands are in Microsoft Office products, as an example, because that tends to be an application space where a lot of people spend a lot of time, and they're complicated, and you can collapse multiple steps using natural language commands. That's in a very narrow domain. So part of the goal in the advanced technology that we're working on now is a focus on expanding out those domains and making these systems much more flexible to understand a broader set of kind of conversational domains. And you can think about the way that some of the mobile voice assistants work, as an example. They're really good when it comes to understanding at first it was what the weather is. You could ask them a question about the weather in 5 different ways and you get an answer. But if you ask them a slightly different off-topic question, boom, you get into a web search. And that's not as helpful, of course. So expanding out those domains of natural language understanding is a key area. And one of the drivers to doing that is a broader investment that we're making in artificial intelligence and machine learning using deep neural networks, so that we basically allow the computing systems to mimic the way the human brain works. And as they get smarter and smarter, they're going to start to expand out the domains that these natural language systems understand.
Just a few days ago, there was news about a recent investment from Amazon and Sony on a new on a system that is the idea is to combine machine learning and using a sort of crowdsourcing some work with students to try to identify accents around the world to improve the way our sounds and how everything is being recognizable, and now you can use different systems around the world without any difficulties. So this is, this process was a little bit, let's say, manual in certain way, because it was using the work of students to dictate and to speech. So in with such diverse number of companies try to work on this area, I think that the fact that you have to work, the fact that you are working in the area of accessibility, but you somehow in some of the advantages facing the difficulties that you have to face, or this is still an area that is so in the open that we are still at the beginning of being able to build a product, like Neil was saying, could help us to actually create something relevant and easy to use?
Yeah, it's a good question. There are a few questions within there. One is, I guess one point that I make is that the whole idea of flexibly understanding the variability of speech patterns and accents is something that we focused on for a long time. In fact, the earlier versions of Dragon were quite focused on its ability to rapidly adapt to the way that an individual speaker spoke. The latest version of Dragon that we just released back a month ago or so was the first time that we incorporated this deep neural network technology embedded within your computer. And because of that, it has rapidly improved this self-learning technology. So we found that accented speech is now much more accurate than it's ever been with Dragon by applying these new technologies. So I think you're going to see more of that. Now, it's a combination of the technology, the deep neural network technology that we've developed, combined with what you were mentioning before, Antonio, was the broad data asset. Because you need to start these things out with, start these systems out with a huge amount of data, because when they get all the variations of speech patterns, as an example, that gives you the ability to build a model that is going to be far more accurate. And we've had the advantage of being in this business for a long time, and with the people who opt in to provide us with this kind of data, you get a amazing amount of data that you can use to train these systems.
Do you think that more and more the systems will learn about the user itself, so it will be more personalized in the way how it will work?
Yes, that's a key part of this kind of learning technology, right? They need to adapt to the individual users, and adapting to users is a bunch of different things. Of course, there's not only your speech pattern, and so the way that you pronounce certain words. I've noticed that you speak English a little bit differently than I do, as an example, but also the words that you choose to use, right? So your language model, meaning your speaking style, the way that you interact is different. Not only the audio, but the content is different. So understanding that. And then the third thing is your preferences, right? You may expect to system in a certain way. You may expect things to be, if you're saying something for writing purposes, as an example, you may expect it to be formatted in a certain way. So all those unique characteristics of you are things that these systems need to understand and personalize to the individual. The trick, though, is making sure that when you need it, but you also need a broad capability for speaker-independent technology, so that if you're dealing with public access, as an example, you need people to be able to interact with systems and technologies in a way that's very flexible, know about you for the first time. So it's a combination of those factors that are quite important.
Peter, I'm fascinated by this conversation, and I was really stoked when Neil invited you and you accepted. And I have 1,000 questions, but I'll try to calm it down. But I love the work that you do, because, and so coming at this from a couple of different perspectives. First of all, I always find it interesting how the universe prepares us for our lives. So you were doing all this work, preparing for this beautiful Mary. That so how old is your daughter? She's
15 now. So.
And so Mary Ann. So
Yes.
That's I'm fascinated by that part. I'm fascinated by the part that you were an IBMer before you joined Nuance, and because IBM has done so much. They have such a powerful history of creating products and services that help individuals with disabilities, but we take those as a society and say, wow, what else could we do with this? And I often talk about a story in some of my speeches that IBM created text-to-speech, speech-to-text, certainly to help individuals with disabilities, but then the engineers at IBM said, wait a minute, I think we could use this for our automobiles. And now we have all kinds of things talking to us. So I'm fascinated by that. And I also wanted to tell you, I have a daughter that's 29 years old, born with Down syndrome. I talk about her often. And Easter Sills, whenever we were told that Sarah had Down syndrome when she was 4 months old, Easter Sills stepped in and just wrapped their arms around us. And we featured Easter Sills on AXSChat before, but I'm a huge fan of Easter Sills. When my family got in a really bad place, we just didn't know what to do. Easter Sills swooped in and protected us, and I will always be grateful to Easter Sills for that. So we share that in common. Yeah, it was really... It
is a remarkably small world when you start to enter this area. You know, you mentioned my history working in assistive technology back at PC, and how that came in handy later on in life was interesting. Of course, I find that it's such a small world that everybody that I talk to knows many of my close friends. You were talking about a dear friend of mine, Francis West, who we share, who's the former, recently retired Chief Accessibility Officer of IBM, as an example. And I've had a long history with IBM, not only working there, but partnering with them over the years. In fact, Nuance has had a very productive, positive, long-term joint research collaboration with IBM because we share many of the same values and interests around applying this technology to the world. So it is a small world.
It is a small world. And, you know, I'll tell you, I have, my son was Kevin, who we've also featured on AXSChat. He is 27 years old. And when he was going into high school, my husband said, you need to take a typing class. And I'm like, you don't need to take a typing class. I think he was in middle school then. I said, by the time you get to high school, we're not going to be typing anymore. We're going to be talking to the computers. And so I was a little behind in my predictions. But right. It is fascinating what we've done. And often on this program, talking to Neil and Antonio, we really talk about, like you mentioned before, the future of work and where are we going. how does assistive technology move into the mainstream with everything else that's happening and what Google's doing and Apple's doing and, you know, IBM and Atos and all the Internet of Things and the wearables and the robotics? It's fascinating where technology is taking us. But then, of course, we're about individuals and family stories and our individual. I mean, Neil is always very open about having dyslexia. And so he uses, you know, your products in different ways than, for example, I use it or some of my team members use it. So it's fascinating to watch the human and the technology really come together in such a powerful way, and to know that we have leaders like you that are part of the community, really understand what the needs of the community are and where can we go from here. It's very exciting about the future.
Yeah, it is, and I think that there's a, you know, I'm a big believer that technology will improve all of our lives, and it's not that scary. You know, people are sometimes scared of the machines taking over. I think that technology applied correctly will help us all in different ways. And you know, we mentioned Francis West a few minutes ago. Francis was a big advocate of the idea that abilities at different times, and just because some people have a permanent disability doesn't mean that other individuals may have a temporal impairment, right? That may be an injury, it may be age that we all face, obviously, or it may be just a situational impairment. As an example, you're driving your car and you need to interact with technology. So the idea that technology and assistive technology is broadly is helping us all in improving our society is I think an important point to make. And we need to remember that, because of course the assistive users tend to be the beta testers for
right.
all new technology, and they're the beta testers who pay more for it. So we need to keep that in mind and find a model that works for everyone, that continues to move the ball forward with assistive technology, encourages the innovators to invest in this area, because it's quite expensive, of course, to innovate this kind of technology, with the ultimate goal of helping everyone, because it will have a very, very broad impact in the world for all of us.
I agree. And Frances West and I have been friends many years too. I had the pleasure of seeing her son get married in Virginia in a lovely wedding. And I think that we're going to see a lot of continued greatness from Frances in her retirement. I will tell you though, and then I'm going to turn it back over to Antonio and Neil, but my husband is, as a matter of fact, Sunday is our 34th wedding anniversary. So we've been together a long time. But my husband, when he went to the iPhone 6, his fingers are too big. And so I'll ask him to type a message while I'm driving, so I'm being, you know, safe. And he can't type. And so what he uses is the text to speech, because it's easier for him to speak to the iPhone, because every time he goes to use a keyboard, he hits multiple letters. And I see that with other men, particularly that have bigger fingers than I do. And so it's just become such an important part of our society. And I think there's so much more to this than even I realize. And once again, where we're going, I just think it's very exciting. And Antonio, I'll pass it to you. I know you want to make a quick comment, and then we can go back to Neil.
No, you know, today we see so many technologies, you know, virtual reality, machine learning, Internet of Things. What I'd like to know, when you go back to the beginning of your career, and if you look back today, how do you see this evolution around accessibility, even around the interest and the impact in different countries around the world?
It's a good question, and I think when I started getting involved in assistive technology back in the 1980s, I had an extremely narrow view of what that meant, extremely narrow view of disability, so I think my vision was probably a little bit different for how things would go, because again, my worldview, growing up, I was born in the mid-'60s, and at that time, with less inclusion in schools, I didn't grow up around people with disabilities. So for the first time, I had the opportunity to work with people who had disabilities in college. It was very narrow, right? Because they weren't part of my world, my vision was much more around the idea of using technology for people who had, because that's what I experienced. What I realize, of course, is that there's such a broad range of technologies and broad range of disabilities that I think there's a more fundamental way that computing needs to evolve over time to just be smarter and more responsive to humans. But if I look over the last few decades, I think the earliest technologies that I saw applied were really focused on physical barriers. But I'm seeing much more, as information is so much more central in our life, you're seeing technology being applied to informational barriers. Because, of course, we've seen the power of information. It's changed governments in the last few years with the radical openness of technology in the world. But why is that limited only to people who have the ability to interact using standard methods of technology? So we've seen that improve significantly. I think the area that I see that needs a lot of innovation is the whole area of transportation. I'm quite excited about the development of autonomous vehicles as an example, as sort of the next area of broad technology, and it leverages all the foundational work that's been going on for the last decades to start to provide sort of that next level of freedom of access around transportation.
Fantastic. We used to actually joke about using Dragon to control cars and talk about scratch that.
Right.
Has multiple meanings, obviously. So scratch that being the command for Dragon for undoing something that when it's got something wrong, although it doesn't need it as often these days. So I've got a question, and it's about the sort of ubiquity of speech, but also about and it's kind of tied into robustness, because whilst there's amazing technologies available in the cloud, the cloud technology is still pretty much reliant on you having a connection all of the time. And despite ubiquity of internet connections, as Deborah will prove, it's not always as ubiquitous as we think. We think that broadband's everywhere, and it may be that you can get better broadband signal or 3G signal in the Kalahari than you can in Virginia, but where a lot of these speech services have been served up in the cloud, I think that the mobile devices we have these days, they're far more powerful than my PC that I ran Dragon 5 on. Many times more powerful. So what are the prospects for sort of and what's the balance between on device and in the cloud? Because I think that a lot of people who really need assistive tech need that sort of assurance that it's going to work regardless.
Yeah, it's a good question, and one we debate a lot, right? Because the major question is time, right? Because we know, if you look at when I started using connected services, it was with a 300 baud modem. And I think many people don't even know what 300 baud means anymore, right? But so incredibly slow network connections. And now we have much broader coverage of cloud connectivity. And I think 10 years from now, with all the work that's going on from in many parts of the world, I think we're going to have incredibly high-speed, virtually ubiquitous network connectivity. So the question is when, and does it make sense in the short term to focus on focus investment in the area of more embedded technologies? We think there's probably a balance. More can be done with embedded technologies. Certainly some of the mobile devices that are available today are extremely powerful, much more powerful than we would have imagined a few years ago. In fact, we do provide some embedded technologies into mobile devices, not the full Dragon yet. And the reason we don't have the full Dragon available on a mobile device has more to do with what comes along with Dragon. The hard part of Dragon is, believe it or not, is not the voice to text. That our research guys would be mad at me if I said that. That actually is quite difficult, guys, I promise. But there's another very complicated piece, which is interacting with the operating system. And people who've used Dragon for a long time know that it works really great in some environments, but if you get to a website that doesn't conform to any kind of accessibility standards, or if you're dealing with an application that doesn't conform to some standard accessibility APIs, it's not going to work as well. And there are some limitations. It gets much, much harder on a mobile device. And in fact, some devices, the iOS as an example, is not really designed for a third party to put a system on it that is a fully, has full capability because of application sandboxing to communicate to the other applications. And Android is a little bit more open like that, but comes along with complications with all the multi-variants of Android. So it's a complicated thing. I'd suspect that the answer is going to be better cloud connectivity in the short term, although you may see some continued improvements on embedded mobile devices.
Okay, great. That's a good answer. And I know that your research guys do a lot of work, and you're doing clever stuff with hidden Markov models, and it's not trivial, the work of recognition. So I know we're at the end of our time, so thank you very much for joining us today, Peter. It's been a real pleasure talking to you. I've been a big fan of Dragon. It helped me get my master's. I dictated everything, including my exam questions. I over-dictated one as well, and then it dictated all my swearing, because I turned to the invigilator and asked for the time, and I'd actually highlighted my answer. So yeah, Dragon's great. So
great. Well, thanks so much for having me, and I really appreciate what you're doing with your content here. It's really, really important to get the message out and continue the dialogue about assistive technology in our everyday lives. So so keep up the great work. I really appreciate what you all do.
Thank you, Peter.